Hey guys, how you going? My name's Sam and you're watching another core electronics tutorial, and today we're going to be taking a look at switches. Now, switches are really important to understand, even though they're pretty simple devices, because electronics, everything about electronics is made up of switches, be it mechanical or electronic. In fact, the chips that power your phone, TV, computer, every electronic device ever is really just a whole bunch of tiny little switches. We're at the point today where we can fabricate and manufacture a transistor, which is an electronic switch controlled by an electrical signal. We can manufacture those in nanometers, incredibly tiny, which is why there's millions and billions packed onto a tiny little processor or a circuit board. So let's take a look at how switches work and how they operate. Today we're pretty much going to be looking at mechanical switches. Everything operates on ins and outs. So most embedded circuits, most projects, most everything operate on inputs and then doing something with that to outputs. And there's lots of different types of inputs, but primarily almost every device that you will see has some kind of button, some user feedback, where you can define a state using a mechanical input, be it a press or a rotation or something like that. So before we get into it, let's take a look at some key terms that are important to understanding switches. So first up, there's two main types of switches. You have latching and you have momentary. Now, most switches are pretty much just derivatives of these types of switches. Now, latching means that the switch will hold its position mechanically when it is turned or pushed or toggled into a state. It will, so take this switch for example, you can hear a definitive click and then another click, and that's toggling between two states and it's latching in between, like the clicky point on your pen. That latches, it doesn't have to be held there constantly when you want to write. Now, momentary switches are the opposite. They are, momentary. So, if you imagine the clicky point on your pen again, except when you push it down, the pen nib comes out, and then when you let it go, straight away it goes back up. It doesn't hold its position. That's a momentary switch. So it's really good for, selecting an input or changing something momentarily that you might want to be used as like a press and hold kind of switch, and when you release it turns off, or a pulse that can be read by a microcontroller to develop a latching function or something like that. But yeah, that's momentary versus latching. Now, within those types of switches, you've got two main characteristics which define how the switch operates: poles and throws. Now, poles are a bit like the individual channels, like signal channels that can be switched. So if a circuit has a single pole, in fact, let's draw a switch. I hope you guys can see this. So a typical schematic symbol for a switch might look something like this. So this is a typical make or break switch, and if here you have something else going to part of your circuit and here something else going to part of your circuit, and when you push the switch, it's going to close or activate the switch. It's going to close the circuit and allow electricity to flow, and when it's open, it breaks the circuit. Now, this switch has a single pole because there's only one sort of point there's one channel where the signal can flow. So here we have a single pole single throw switch. So it either makes or breaks the circuit. Now, as we said, the pole is like an isolated channel. So take this switch here, for example. This is a triple pole, 3-pole, double throw switch, and it's a foot switch. It's designed for industrial applications, but most commonly for audio effect circuits. So guitar pedals and effects pedals and things like that, where you need a really durable switch with a nice tactile feel that you can press under your foot. And it has 3 separate channels, which means each one of these pins is isolated from each other, and then they each have their own throws. So in a schematic, you could imagine that inside one mechanical switch, we have another another 2 poles which can be switched and manage their own signals independently. Now, throws are something different altogether. So throws is the number of contacts that a single pole can make. So the number of options, if you will, that that one pole can be connected to. Now, as we said, I'll use this as another example. This is a triple pole double throw switch, which means that to make this correct, there's actually, rather than this just being held open, so with this switch, a single pole, single throw switch, when it's disconnected, that would be connected to nothing. There's no physical contact. There's only two contacts on it, that one and that one. When it's closed, they're connected. When it's open, not connected. But a double throw switch actually has another pin connected to there. So it gives you two states now, rather than just on or off. It gives you two active states, shall we say, that you can toggle between. So you could still leave that pin unconnected and use it as a single throw switch, or say you've got a signal coming in here and you want to, well, this could be a pin on a microcontroller, and you want to toggle the pin high or low. You could have 5 volts connected there, and ground, so 0 volts connected there, and you could use it like that. For example, now it's important to note that switches, mechanical switches, are just that. They're two contacts connecting, just metal, conductive material, which means they're bidirectional. So you could have signal flowing from this direction, so right to left, or you could also have, current flowing from left to right. It doesn't really matter. So that's poles and throws. Now, the last important characteristic of switches is the rating. Not all switches are rated for the same application. So take this switch here. This is a very small, I'll put it on the paper so you can probably see it a bit better. It's a very small tactile push button switch, and it is a single pole, single throw switch, meaning when the switch is not pushed, these two pins are not connected. There's no circuit being made, and when it is pushed, they are connected. When you release it, not connected. It's a momentary single pole, single throw switch. Now, as you can probably see, the legs on this switch aren't very big. They're quite small. It's designed for breadboarding applications. Now, whilst the legs might be that size, the internal mechanisms are going to be different as well. There's no guarantee that just because the legs are that thick and might be able to handle, say, 1 amp, that the internals of the switch can, that the contacts and the mechanisms that are carrying current can handle that. So there's different ratings. So for example, I've got here a toggle switch. Now this guy has a rating I can see on the bottom here, and you'll find it on the product sheet, but if you can't read that, it says 2 amps at 250 volts or 4 amps at 125 volts. So switches are rated for power. So I could use up to, so if you know power is equal to voltage multiplied by current. So 250 volts multiplied by 2 amps gives us 500 watts that this switch can handle. Now, also, you can divide the voltage by 2, which 125 volts, and you could increase the current capacity to 4 amps, which is fantastic. So these guys are designed for, handling mains current and things like that. So, you've got different ratings of switches. These guys might be only able to handle, milliamps and, say under 24 volts or something. So ratings are really important to observe. If you're using them in, small, low power microcontroller settings, and really any switch you like, is going to be fine within reason. But if you're doing it for battery supplies where you're drawing a lot of current, or mains power, if you are safety certified, then you need to be aware of that. So that's a bit of an overview of the characteristics of switches. There's some diagrams in the written tutorial for single pole double throw, double pole double throw, triple pole double throw. Now I've got here quite a wide variety of switches that all perform different functions. They take different forms of mechanical input to achieve the same thing. So here we've got a joystick. Now you might be familiar with this if you're 20 years and older from arcade systems and things like that. And it is a joystick. It is designed to give directional movement or menu selection or things like that to a user. Now it's actually incredibly simple. You have 4 sets of switches here, and these are single pole, single throw switches. They're make or break switches. You can see here there's the 2 contacts there, 2 contacts there, 2 contacts there, and 2 contacts there. Now this joystick simply makes a connection. So you can see the other arm of the joystick here. It's making a switch connection here, and there, and there, and there. So it really just makes a switch in either direction. And by combining both switches on on this side and this side are connected, then you know there's a diagonal movement, different things like that. So incredibly simple, you get directional input from 4 sets of switches. Now again, simple arcade push button switch, and I can see from, I don't know if you can see on here, but on the switch body itself, it's got a little circuit diagram of what the switch does. Now this is useful for recognizing the type of switch it is on the fly. Now you can see there's a little, this is the switch itself, and there's a little actuator in there which I can get in with my pen and trigger. And then this plastic bit is just the body. It's an arcade style button, and it's got a little arm there which activates the switch, and it's a single pole double throw switch, hence the 3 contacts. The 3 contacts give it away because a single pole single throw switch would only have 2 contacts. Now this guy is a bit different. This is a rotary switch. So a rotary switch is, well, it's designed for rotational input, as the name implies. But where it gets a bit, different from your other types of switches is a rotary switch usually only has 1 or 2 poles. This guy has 1 here, 1 pole, but it has a large number of throws, and it's designed so that you can select a whole bunch of different options just from a single control where, say this switch is a binary choice switch, you get on or off, selection or selection. This guy, I think, is a 12 throw switch, so you get 12 individual positions that you can turn it to. Now, rotary switches come in 2 flavors. You have the ones which make 12, for example, 12 individual circuits. So you would have 1 contact here, which is, say, your signal contact, and then you would have 12 other different contacts. I mean, that's not 12, but there's a lot. And pretty much, it just looks a bit like this. You've got all these different switch contacts, and depending on which one is selected, current will flow through that selected channel. You've got another type of switch like this, and these ones are designed for analog input to microcontrollers, because instead of having lots of different outputs, you can see it's got a connector for a sensor cable here by DF Robot, and it only has 3 pins. So, how do we get that? Well, what happens is it utilizes a resistor ladder. So we have 1 input here, all right? And then there's a bunch of resistors. You can see the resistors, along here, and this guy will, in fact, so this is another type of rotary switch. They're not all this way. They're usually one or the other, but there's a bunch of different value resistors here. So let's pretend that there's 12 resistors there. And essentially you've got a bunch of different switches here which make or break the resistance, and these are all tied together. Alright. And so signal is going to flow through only one of these resistors, and you have different resistor values, a resistor ladder. So that might be, say, 100 ohm, that might be 500 ohm, that might be 1K, and so on and so forth. And by creating a voltage divider with those, you can read an analog input on a microcontroller, and using only 1 pin, you can get 12 different possible scenarios based on the voltage that you're receiving to that pin because of the resistor ladder that is created. So it's really cool. Ooh. And there we go, fantastic. So there are a few different types of switches, and the rest of them really are variations. So, different mechanical actuators. So here we've got it's called a lever micro switch. So it's designed for incredibly low force to be applied, hence the lever. Lever action, creates an increase in torque from the mechanical input to where the switch is. And it's designed for, really small, fine applications where you just want a really small, force to trigger that. And the 3 pins gives it away that it is going to be a single pole double throw switch. I can see on, and C, so probably common. So then we've got, a slide switch, which is again a single pole double throw switch, but instead you've got a slide actuation, useful, you find those on consumer electronics, things like that. Now here we've got a waterproof switch, and this guy is pretty unique because along with being, a nice durable, sleek, industrial looking metal housing, it's also got an LED built in. So if you can see that dark ring around the outside there, that is just some transparent plastic, and there's an LED mounted inside here with individual contacts to control the LED. So you could hook this up to a microcontroller, and it's a momentary switch, so I can feel that the switch is going to the same point, and on the data sheet it says that it's a momentary switch, and you can tell that you could use this for a whole bunch of different applications. You could control, a microcontroller input and then have the microcontroller control the LED, or you could hook the LED directly up to the switch contact. So when it switch, when you're holding it in, the LED turns on, or when you release, it turns off, things like that. And then lastly, your standard kind of toggle switch. Now this guy is a single pole, single throw switch. I can tell because there are only 2 contacts on it, it's going to be a single pole, single throw switch, and it is on or off. Generally designed as a trigger for things like control interfaces, or for master power switches, things like that, where you want a really clearly defined simple switch. So that's a few different types of switches and how they work. And the last thing that we're going to cover is a phenomenon called bouncing or switch jitter. Now, let's turn over. You might think that, let's take this switch here, for example. Now this is a very small switch, and you might think that when I push it, let's say we've got it connected up to, connecting to ground, and when it's unconnected, we have a high voltage. It's been pulled up. So if this is our 5 volts and this is our ground, or 0 volts, when it's not being pressed, we might have a nice high voltage, excuse the squiggly line, and then when it's pressed, it falls down, and then when it's released, it goes high again. Now that is generally how they're designed to operate. But the important thing to note is that inside every switch, there's mechanisms. There are mechanical contacts which have to make contact in order to allow electricity to conduct. And like anything mechanical, those contacts, have momentum, which means that when they make contact with each other, they have momentum, they have a velocity and a mass behind them. So they're going to actually bounce, because when they hit, they're not just going to sit and stick. They're going to bounce. So they'll hit, connect, and bounce, and then finally settle. So you might have hit, connect, bounce. All right. Now, the bigger the switch, the more momentum that the contacts are going to have. So take this switch here. This guy is rated for mains voltages, which means it needs to be able to handle 2 amps at 250 volts. That's 500 watts of power. That's a lot of power, people. That's as much power as a typical desktop computer would consume, and that's a decently powerful one as well. So the contacts in here are going to be big, they're going to be heavy, they have to be rated for that kind of current to go through them, otherwise they're going to get too hot and melt the plastic or destroy the entire mechanism. So why you pay attention to the rating. But because they are big and they are weighty, they have more momentum. As we said, momentum is a function of velocity and mass, and the greater the mass, the greater the momentum. The greater the momentum, the more inertia they are going to introduce into the system, which causes bouncing. So a really small switch might only bounce a tiny bit. A really big switch might bounce quite a lot, which gives you a longer time period. So what you have to do is use debouncing. Now this isn't important if you are using this as a on-off switch for mains power, or for something like that, or for a selectional switch where it's not timing sensitive. It's not going to matter if for an extra 10 nanoseconds there's this sort of debouncing, because it's going to settle pretty quickly. But if you're using a microcontroller, for example, where you're reading the state of this push button, microcontrollers operate anywhere between 2 to 4 megahertz, right through to gigahertz. Really high processing speeds. And this is important because if you're sampling the pin that's there, instead of being this nice clean break, you're going to get, it'll go down, and then it'll go up, and then it'll go down, and then it'll go up, and then finally it might settle. And then likewise, when you release it, there'll be this jitter on either side, and you're going to need to handle that, because if you're, say, turning an LED on or off with this switch, you're going to get false positives, and it's going to, if you're just sampling that straight away, it's going to say, oh, you turned it on, then off, then on, then off, then on, and then on, and then off, and off, and so on and so forth. And that can be a real issue. So you need to use what's called debouncing. And we're not going to go into debouncing in this video or this tutorial, because it's another conversation in itself. There's a lot of different ways you can do debouncing through hardware, resistor, capacitor, filter networks, and Schmitt triggers, and flyback diodes, and all the rest. Or you can implement it in software by just limiting the amount of times that you can that button can trigger an action for your microcontroller. So we'll get that tutorial up for you so you can take a look at that. But pretty much every project that we do, or every tutorial where there is debouncing, you're going to find some form of switches, you're going to find some form of hardware or software debouncing in there, because it's really important. So that's just a few things to consider when you're using switches in your projects. Now I hope this has answered a few questions. If there's something you're unclear about, or you'd like us to go into more detail on it, hit the comments below, get the conversation started. We'd love to hear some feedback on how useful this was to you, and some projects that you guys have made using this information. Don't forget to subscribe, hit the like button, whatever platform you're viewing this video on, and stay tuned for more awesome analog electronics videos and tutorials. I'm Sam, and I'll see you next time, guys.